So when you build up a conference and you plan some sessions, you don't really know what to expect, right? And I'm so happy that so many things I will show in the next, I'm afraid, more than 20 minutes are already somewhat shown by other users. So I want to resonate a little bit on one question, and the question is, why are knowledge graphs not mainstream yet? And we had this discussion with many, many people, and Aura recently said in a podcast, maybe knowledge graphs are mainstream when people don't ask anymore or say that they solve this problem with knowledge graphs. And I think we do have these use cases, but I want to reflect from another perspective, which was mentioned twice, first in the BMW presentation and just now by Cedric as well. So Aura did this article with Tim, and we learned it was in 2001. If you don't remember how long ago this was, first this one, we had this one. Aura had the quote from this slide. This was shared on Twitter by a colleague of Aura. So this is basically the blessing from Gartner that people should do knowledge graphs, and this will definitely help. We just saw that on Cedric's slide as well. So this is important to get the blessing, even if it took Gartner 20 years to figure that out. So how long was that ago? When Aura wrote the paper, that was between that phone from Nokia and that phone from Samsung in Matrix Reloaded. So it's that long ago. It's crazy when you think about that, because our phones definitely don't look like that anymore, right? So why did it take that long? And I want to exactly come back to this data, information, knowledge, wisdom pyramid. This is a little bit a different view on here, and I want to quickly show you some interesting things in here. So we start, imagine this is a stair. We start on the bottom left part, we start with characters and signs. We start to add syntax, we get data. That's what we do for quite a long time in IT already. And our claim, I would say, in semantic web is we add the meaning, the semantics, and we get information. So I think we can safely say we are on the information layer now. And 10 years or so ago, Google started to call stuff knowledge graph, and since then everyone, including me, talks about knowledge graph because you need to sell the stuff on the wave, right? Not under the water. So this slide, which is done probably before knowledge graphs were actually a thing, says to get from information to knowledge, you need to add interconnection. And what is interconnection? It's context, experience, and expectations. I will get back to that for the rest of this presentation. And then when you have knowledge, you can do actions. When you have actions, you get competent, and then you are competitive. So you add these things on the right side. The interesting thing is that the thing here, that's not a laser pointer, good to know. So the culture and value part on top and the IT part overlap on the knowledge layer. So this gives an interesting question. When we say knowledge is information and interconnection is context, experience, and expectations, can we actually store this stuff in a digital way? From the same slide set, this is from a training one of our colleagues took. I didn't translate that, but I will explain it to you, is this image here. So it says direct, so the top layer is knowledge layer, right? So when we talk to other people, we exchange knowledge directly. That makes sense to us. That's the way we worked for a very long time. When we put this stuff into a system, this slide says we turn knowledge into information, which means that we are semantically losing something, right? And then the claim of IT systems is that when we add some fancy front end of some form and someone consumes this is the 4, they generate knowledge again. I was very, very enthusiastic back in the days when wikis came up. I started to put everything in wikis. I forgot that I even put this stuff in wikis because I never ever found it again. You know, like this know-how was simply a waste of time for a big part because it didn't transport the things in a way that someone else could either find it or use it. So these fails. So my question is, later, will knowledge graph solve this? But first, I obviously have to say, will LLM solve this? And we already know the answer, no. But I have this very nice example, which I found super funny. So this is from a German short article I translated it. So it says, undercover investigators, disguised as bananas, the officers seized no less than 740 kilos of cocaine in the supposed fruit crates. Just picture that in your head, what it actually means. So I asked ChatGPT, can you explain me what happened here? And he said, the sentence disguised as bananas acts as a descriptive phrase indicating the manner in which the officers were disguised during the operation. And I said to my colleague, ChatGPT didn't get it. And my colleague said, no, it got it. It's simply wrong written. So that's exactly my point. Every one of you understands that the police officers didn't look like the guys from Arrested Development, but ChatGPT has a hard time figuring that out, even if it was probably trained on many documents about police seizing stuff in banana boxes, right? While I was doing this slide, I actually found this one on LinkedIn. The credits are on the bottom right there. And this is exactly the same thing. When you put this in a knowledge graph without saying on what the emphasis was in this sentence, you don't really know what was the message in there. So we lose, again, context, experience, expectations in here. LinkedIn, another horrible example. I really don't know how people use that. I mean, thank you for everyone that added me. I will never, ever find you again in here because I can search for names. I don't remember names. I can search for company names. I don't remember names. I can search for where you live. Totally not useful. I cannot search in a query like, I met this person in Jakarta last November at this conference, and among other stuff, I talked about cats. This is what I remember, and I will never find this name again because I cannot search it that way in here. So if this is a knowledge graph about people, it's utterly useless from a user interface perspective to me. So what do we do with knowledge graphs? We do stuff like that, right? Fantastic. So credits to MetaFacts here. This is the fork of the last not closed-sourced version of what was called Ontodaya. We call this Graph Explorer. I like it. I use it. It's nice when you quickly want to explore RDF in a raw layer. But I sometimes tell people, like, this is like looking at bytecode or assembly when you write programming code. You know, you have a lot of extra nodes which are super useful for you for the, I call this the timeless graph, the graph you need to have to keep all the information in there. But when you show that to people, and we will see the same data in the rest of my presentation, it's useless. You cannot do anything useful as a normal person with this visualization. Then we had one client, someone sits here from this client, which said, let's do something nicer. GraphDB has a nice front end. Let's do it a little bit like this. So we did a GraphDB-inspired thing, but it's a little bit augmented, if you see. So SAM has an icon as an application, because we said applications can have icons. OK, MetaFactory can do that as well, but not the point. And then I have data flows. These data flows can be indirection. It can be a path in this model. It's already a meta model. So we modeled here applications and how they send or receive data from other applications, how we send business objects over the wire. This is a typical enterprise architecture use case. So the first picture is acceptable. You see incoming, outgoing stuff. OK, you can figure out what's going on. Then you expand it, and it looks like this. And I was super proud, because I told my colleague, look, we modeled it in a graph. It's all in there. And he said that this is utterly useless. So what people actually see when you show them stuff like that is this. They don't understand the graph. They couldn't give less fucks about the graph. That's not the way they expect the data to look like. So he came back to me, and he said, I wrote this thing manually in Archimate, or Archi, I think is the thing. The standard in enterprise architecture is called Archimate. The colors, the boxes, the arrows, the dots, everything has a semantics in here. When you show this to an enterprise architect, they immediately understand what the purpose of this thing is. It actually says the thing in the middle, the application SAM, is receiving data from these three things on the left, and it's sending data to these three things on the right. It's the same thing I showed you before. It is in the graph exactly modeled like this. So he told me, build this. So we did, I thought. So one of my colleagues, Giacomo, which is also here, he did something super, super cool. It's called RDF2dot. If you're old enough, you remember dot and rendered RDF in dot. It's still the best auto layouter. So Giacomo said, let's take the following idea. We create a minimal vocabulary, because we are RDF people, right? Semantics. The vocabulary represents the capabilities of the visualization you want to have. And then we transform the input graph in that representation and render it. And we all know that this is super, super easy with RDF. RDF is the perfect data transformation things. We can do that with Sparkle constructs. We can use notation 3. We can use data log, as we saw this morning. There are many, many ways of doing this in RDF, and it's super, super simple. We can decompose these things in rules. We can chain them, and so on. You can really offload the complexity here. So this idea is brilliant, and remember this idea. We will get back to this. So I took it a shot. I did this RDF to dot, and I said, OK, this is basically what you showed me. I went to him and said, look, problem solved. He said, you didn't listen to me. You didn't use the colors. You have different orientation. And by the way, the logger cantone here, this should be on the left and on the right side. You have a loop in here, which is correct, but I want to have it as 2 objects. So I was like, oh man, you annoy me. I don't want to code. I'm not a coder. So I figured out Plant UML has a Archimate extension. Some of you probably worked with Plant UML. So did the same. The vocabulary changes a bit, right? Because now I'm on a Plant UML vocabulary, so my transformation changed. Then I created this thing. And I was so proud because I said, like, look, the Canton problem is solved. They are left and right. The spatial orientation is correct. Everything is great. And he told me, like, no. I want to have it exactly the way I showed it. And this is annoying because if we have to build front ends that way, we write code so far. And this doesn't scale. Then the model changes and you're screwed. You have to refactor your front end. We did this with one client for 4 years. They paid us well, but we had to refactor all the time. And this is, by the way, the result of this refactoring. We simplified things. So how it looks like now is like this. You log in. You can search for Sam. And it looks exactly like he wanted to have. And now the cool thing, this is the graph view. You can still do that if you like bubbles. But you can now browse the graph in a super domain-specific way. All the stuff is clickable. And this thing is generic. It gets the new information, it takes the new transformation, and you are done. So it's exactly the way he wanted to have it. And when you expand the graph, you will see that you traveled basically through this graph. So the graph representation follows you. So this is super cool. We can do that for other stuff. Let me give you an example. Once we did that, he came and said, OK, now I want to have an annotation on the line. Because what you basically transport is a business object. So add this business object. Then we extend the vocabulary to include business objects. And when you click on the business object, you get a different, super specific view. You see the business object has attributes. These are these 3 dots. And the attribute over some RDF chains is serialized in a WSGI database in these columns in the table. So you can really start to build super, super specific views. And the team only has to get a simple component. This is HTML and CSS. It's not even a library. It was super, super simple to do because we didn't do much more than boxes, colors, and putting an icon in there. So this we can give to web developers. They will never even see that we use that in an RDF context because we do the transformation on our side in a different layer. So when we start thinking like this, now we have the super, super specific thing, right? Maybe it would be cool to have something between graph and super, super specific like the one I showed you. So 2 weeks ago, this client, by the way, did a super great presentation. Peter, where are you? There, he's there. He did these slides, and I told him, like, these are exactly the slides I need, because otherwise I have to redo it on my own. So he said, there are a lot of trees in our organizations. We have human resources, lines. You have agile organizations, same. You have processes, same. You have technology, same. We can all relate to that, right? And then we take these things and we figure out, like, hey, they overlap. Actually, we see persons probably pretty much everywhere, right? So it starts to make sense. You don't see the tree in here anymore, but for us as knowledge graph people, totally makes sense. And then you can make even a more abstraction. I love this picture. He calls it hairball and says that's what we do. That's what we do every day as knowledge graph people, right? We build these stuff. The problem is when it's in this form, we stop because we think that's the job we had. We are good now. It's all in there, and if you don't get it, it's your problem, not mine. So, back to this thing. We said interconnections is context, experience, and expectations. So when you show a line organization in a company in bubbles, that's not what people expect to see. They expect to see the VCO-style diagrams we wrote for 20 years or 30 years manually. And we really had this. We showed them stuff, and then Peter showed the same thing in this form, and suddenly the management said, oh, now I get it. And I was like, what the fuck are you talking about? We showed you the same stuff, but they didn't recognize the things in these, for them, alien structures. So what do? We start with a knowledge graph, and then in the knowledge graph you start to say what is important for me and what do I not care about. So all these refinement nodes, all the details we have in a knowledge graph, we do not show them. They will never pop up here as a thing. Remember Graph Explorer? You saw everything, every single class in there shows up. So here you curate, and this is one example of our internal configuration where we have Git repositories, Docker images, and stuff in there. This might look completely different. For the other use case you saw before, it's more applications, database schema, data flows, and so on. So you configure that the way you want, and what you don't see in here, you will also say how these things relate to other things. And again, this can be a path. If you don't care about the 3 layers you have to traverse, then you just describe it, and the user interface will hide it for you. Then you start to define topologies. The one on the left is ours. The one on the right is from this demo data set I showed you. Might look completely different because your trees are different. These are the trees. And once you did that, you can start to browse the graph, not in a graph form anymore, but you can go through simple tree structures. This is a database schema. I can assure you no one, which is a database specialist, wants to explore a database schema as a graph. They want to see trees. That's what they used to in their tools for 40 years by now. So you can do that. You don't have to do any specific coding. This is like just standard stuff we see, and we can now map that in a graph. You can still have a look at it in a graph if you want, but it's useless. And we have at Mobiliar, we had tables which looked way, way, way different. Believe me, you cannot use that anymore. This is the same thing in our instance. Here we look at Kubernetes deployments. So we have the whole Kubernetes stack, which we source and add to the knowledge graph. And then you can start to do other stuff. You can use cluster diagrams. You know, there are so many standard visualizations people are used to. But we need to make this stuff declarative. Otherwise, we will code our ass off. We increase a really large code base, and it's not pleasant. So back to the trees, back to the graph. This is when you then map the stuff. So we still see the graph, but don't show this to the users. They don't care. They don't want to see this. We also have other things which we don't capture yet. For example, this is from a demo for the documentation for also the client, which is here, by the way. So my colleague sliced this, and he said, yeah, this is the data view, this is the data flow view, this is the responsible view. And we realized while presenting this or preparing this, we realized we don't have the capability of describing that, so we will have to think about how can we do slices like this in a graph, and how can we present them that people can really explore it in such ways. So, to get from information to knowledge, we need to add context. We need to be able to match the experience and the expectations of the users. If we don't do that, we can do whatever we want. People will simply not get it. And we imply a lot of this stuff. We need to make these things part of the knowledge graph by explicitly saying that these things are trees, these things are slices, and so on. And the really cool thing is, then it's declarative, right? We can use that in other use cases. We use it for rendering this user interface. Maybe someone will figure out, hey, this is useful in another context. For example, decomposing that in a flat table, which we could access via SQL as an idea, right? We talked about this in the morning. So what we do is we push the level of abstraction, which is something we do all the time in IT, but I think IT forgot that they would have to do that on the data level as well. They only push the abstraction layer on virtualizations and things like that. So in data, we have to make things more declarative. We have to have less code. The code is not reusable. If you push it into a knowledge graph, it becomes at least a higher chance of being reused. And visualizations and user experience is about spatial orientation. This is something I really learned with this example I showed you. And I mean, don't interpret too much into this enterprise architecture view. Apply that to whatever problem you want to show to users. A lot of these ideas come from a very old blog post. I just mentioned the name. You should absolutely read this. This was written in 2006, and it's more relevant than ever. It's called Magic Inc. by a guy called Brett Victor. He did also fantastic presentations on YouTube. So last but not least, what is spatial orientation? I can show you another example. This is a well-known text representation. It says polygon, so you can guess this is a shape. That doesn't make sense when you show that to any user in that form, right? When I add some context, like 2 dimensions, I can render it already better. But it still lacks the context because you would expect this stuff on a map. And if you don't know Switzerland, you might not really know where Faido is, or if it's even in Switzerland. So what you do is you zoom out, and then you look differently at it. And that's the way we have to think about our knowledge graphs. Who looks at it? With what package, with what background, with what role, and on which level do they look on it? Is it a super low-level technical person, or is it someone which looks at this as a very high level, which just wants to see some high-level stuff? So yeah, we play more. This is another experiment we do right now. This is a mermaid diagram. You might remember that. So we map the graph to a mermaid diagram. It's not super easy to read, so in the middle is the project. Then we have the Git repositories, the people in our company which take care of this project, and the customer. So we can start using all these existing visualizations. Mermaid, for every single diagram type, they basically created the vocabulary. So all we have to do is integrate that in our front end and be able to map to that particular vocabulary for that particular visualization. Just to prove my point, it's really mermaid down there in the console. And then when you think of this, when you start right now this tool, you get the search result. 2 weeks ago, we came to the conclusion that's completely, utterly useless. What you actually want to see is yourself, most likely. So we will think in the next weeks about how do you start to experience the knowledge graph. It's more likely to what Peter showed here. You want to see yourself as an employee, and not just any employee, you want to see yourself. Because then you see your own context, you see what's in there, and especially what's not in there, which might motivate you to go to the guys and say, hey, why is this part of information not in this system? Then you start building the knowledge graph in ways that people actually find use in it and are motivated to really add more data and consume data from other people in there. So all you saw is called Zazuko Blueprint, and I'm super happy to announce that after promising for probably 2 years, it's public on GitHub since 2 days. The work there is over many years, but I think we have a foundation of something where people can start playing with. It's open source, and we would be super happy to plug that to your Sparkle endpoint. All you need is a Sparkle endpoint. Right now, you still have to write Turtle for configuration, but this will hopefully change. If you want to play with this stuff, talk to any of my colleagues here. And tell me what you think about it, what you need to see that this becomes useful. So yeah, that's it. Thank you very much.
Thanks, Adrian. Great. Are you closing the loop?
I hope so.
Are you connecting the dots? By this, I mean, do you use your graph to create personas, and you use these personas to personalize the UI, look, feel, content, configuration of the application when this person logs in?
So right now, we don't, but it's absolutely clear to everyone that we have to have this. The experience needs to look different depending on what your role is, what the time of the day is. I don't know, we will see, but fully, yes, we have to do that.
Great.
it work?
Oh,
yes.
Yeah.
Thanks for the talk. It looks very interesting. Like, I think one question, and like zooming out a bit, I guess it could be a question to Cedric as well, right? Like the actionability, right? Like, I mean, there's all this effort in modeling, and then you have a model, and the folks who understand the value of models see the value of models. But when you bring it back to business processes or applications, there's always a question of actually, what do I do with this data then afterwards? Querying is one thing, but maybe you want to mutate, maybe you want to, I don't know, file a ticket, or if you have this thing on visualization, and we know that this is a good basis for building visualizations and all sorts of tools, are there examples of tools, and are there sort of case studies where people have done such things in order to make data actionable? Like, are there stories that people can share, you know, and do you have some stories to share?
So I don't have a story to share, but I fully agree that this is the next logical step in this thing. This is exactly what we discussed as well. We were talking about dashboards. People ask me, can I build dashboards? And then my colleague Benjamin always said, like, why do you want to have a dashboard? What do you want to figure out in this dashboard? And then you realize, and then we're back to data log and rules, right? When you reach a stage in this graph, this means you have to do something. So all you want to see is a nice representation of what you have to do. You don't need to look at a nice graph when you can do directly an action out of it. So I don't have an example yet, but I hope that this becomes the starting page in this thing, yes.
Thanks, Adrian. Great talk. It's funny because you mentioned actually Brett Victor, and it just came to my mind actually one of his talk about the human representation of thoughts, I think, in which he actually makes this example where two engineers actually discuss about the wind of a plane, and basically there is a model actually running in real time for them to go. So how do you see actually collaboration on this ecosystem? Because so far this is like a one person, one computer, one visualization. How do you see actually multiple people on the same visualization?
On something like that, based on that, I think it's related to the question Cedric said. You need to have different roles in there. The same data might look more detailed for you when you come from one side than from another side, but you still might make decision based on this data. But the manager maybe wants to have something like, how much money do I save? And you need to know, I don't know, how can I downscale my cluster or something like that, for example. So I don't know yet how we do that, but I think it has to be part of the graph as well and become actionable that we can do this kind of collaboration. How it looks like, no idea. We will have to figure that out. This is the first steps.
Pretty cool, pretty
Good.
cool.
There's someone. Felix.
Yeah, thanks a lot. Great indeed. In various presentations, people already said, large language models are like a user interface, also like a user interface for knowledge graphs. So what you showed here, I'm wondering how you see this, if also large language models could be a user interface for configuring the user interfaces. So for what you just said, the vision you just described, when I'm just saying this, I'm an enterprise architect, I have these requirements on the UI, and the large language model then chooses from the components and from configures them the right way. Do you think that would be feasible?
I honestly don't know, but it's a super interesting idea. We should try it out, actually.